Welcome back, guys. Today is day 18 of this Leetcode's 30 days challenge, and today's question is minimum path sum. Even though it's saying day 17, but it's actually day 18. So there are 2 weeks have already passed, 14 days plus the fourth question, and today is the fourth question that we are going to solve. So this is the 18th day, and today's question is minimum path sum. Now, in this question, we are given an m cross n grid that is filled with non-negative numbers, and we have to find a path from top left to bottom right. So this is the 2D grid, and we have to find a path from top left to bottom right. And we have to. There is a condition that we have to minimize the sum of all numbers along the path. So each of these numbers add up as we reach from top left to bottom right, and we have to find the path that gives us the minimum sum. You can either move down or right. This is also one of the condition. So if you check in this 2D grid, the minimum path sum will be 1 3 1 1 1. So that comes out as 7, and that is the output expected in this case. So let me just reset my question. So this is the path that we are given. So in this case, what we'll be doing is we'll solve this recursively. So every time for a particular node, we'll just ask what is the minimum distance from if we go from the right, and we find the minimum distance of if we go from bottom, and whatever is the minimum of those two distance, will add the node will add its own value and return the function. So this will be pretty simple recursive function. So in this case, we'll be creating another min path function, and we'll just pass in the node from where we want to start. So we'll start off from 0 0, and this is our nth function, which will be solving this part recursively. So it takes a 2D grid of integers and a row and a column. Now what we'll be doing is we'll be just calling this recursively by let's say first going down. So this is the down min sum, and there will be a right min which will be obtained for the minimum path if we go right. So going right simply means increasing the column by 1. Now the base case in this case will be that the row actually became greater than or equal to grid's length minus 1, grid's length if it goes out of bounds, or the column became greater than equal to grid for that particular row dot length. If this happens, then in this case what should we return? Now since we are trying to find the minimum path, so the next step here would be finding the current min distance, which will be just the minimum of this two, down min and right min, plus whatever is the value for the given row and column. This will be the minimum distance that will be returned from this function. Now if during iteration we end up going out of bounds, the minimum that we'll find in this case, if we return 0, then that will be taken as the minimum path, even though it is actually going out of bounds. So ideally we should return a maximum value, so that when we try to find the minimum, we end up getting the right value, and not a value that takes us out of the grid. So what I'll be returning is the max value in this case, and for the edge case, when we actually reach the bottom right, so in that case I'll try to avoid the iteration, and I'll just check if the row became equal to the grid's length minus 1, and the column also became equal to the uh, for that particular end. For then in that case I'll just return whatever is the value for that, for the last row and column. Now this is a good enough solution, but if you try it out, so this is actually solving something multiple time. So if you look at this grid, and let's say I'm taking example of this subgrid. So from 0 0, you are one path which is going right, and the other path is going down. So the path that goes right, which takes from 0 0 to 0 1, and there is another path which takes us to 1 comma 0. Now uh, from here, there are also two possibilities. One will go down, and the other one will go right. And the same thing will happen for the number 7. It will also try to find recursively the min path if it goes from bottom, and the min path if it takes the right branch. So what will end up is calculating this node twice. One when we are calculating it recursively for when we take the step down from 3, and the other time when we take the step right from 7. So what we want to do is to avoid doing this recursively, we'll store the minimum distance that we found in by creating another grid. So what we'll do is in the beginning we'll just cache the minimum distance that we have found. So this will be the 2D array which will store the minimum distance. Now the number of rows will be equal to the length, and whatever is this, and what I'll do is I'll try to fill them up with the maximum value, so that during iteration I can easily check if the value has been already calculated or not. So I'll just fill all the elements uh, with the maximum value that I can find for that particular integer. So I'll just use arrays.fill, since we cannot do it directly for 2D grid. So I'll use this function for a particular I. I'll just fill them with the maximum value that I can find, and I'll pass this 2D grid as for caching purpose, for storing the results. And this will be the min distance, or whatever is the cache distance. Okay, now so what we'll do is before returning this value, what we'll do is cache it, update our min distance with whatever row and column value that we found, and this is the current min that has been calculated. And what we'll do is we'll check if the value has already been cached for a particular row and column, meaning it is not equal to integer dot max value. Then we can just directly return from that particular node. We don't have to recursively find the min sum path for down and right again. And yeah, so let's see if this works. Okay, min path sum. What did we do wrong? No suitable method. Oh, in the recursive function we have to pass this dash as well, so that further down the stack it can be reused. So let's run this and check. Yeah, so it is working as expected. So let's submit this. Without using this cache, I was getting time limit exceeded exception. So that our solution is accepted, and our solution is among the top solutions. So that's all. If you like this video, give it a thumbs up, and to subscribe to my channel when I upload the day 19 problem. We are almost reaching the end of this 30 days challenge, and I appreciate you following up until now. So thank you.